Alright, so for this video we're going to see an example using the TI calculator, and we're going to use the same set of data that we had before. Alright, so remember we're running a chi-squared goodness of fit test. We're going to be using the data set of M&Ms based on what we observe in an individual bag versus what we should expect as told by the Mars Candy Company. Now remember, when we were talking about this in the notes, we came to the conclusion that we would fail to reject the null hypothesis here despite having a p-value that was close to 0.05 because it was not quite below that threshold, right? So let's see how this works, right? We have our observed column and our expected column. And you'll see why you kind of have to put this in a spreadsheet, right? So let's go through and input what we have for observed. So on our list we had 9 blue M&Ms, 8 orange M&Ms, 12 green, 15 yellow, 10 red, and 6 brown M&Ms. We were told that out of the 60, based on what Mars Candy Company was publishing, we should expect 14.4 M&Ms that were blue, 12 that were orange, 9.6 that are green, 8.4 that are yellow, 7.8 that are red, and 7.8 that are brown. Now, you'll notice I'm inputting the actual expected counts here. Sometimes you'll be given a problem that doesn't give you the actual expected counts. It'll give you the proportions. What you may have to do is input the proportion that is given times the total number of M&Ms that you have in your sample so you can see what to expect. So for example, in the problem that we had, it said we were supposed to expect 0.24 to be the proportion of M&Ms that were blue, right? So 0.24 times the 60 M&Ms that we had would give us 14.4. So your calculator is smart enough to know this if you're using the TI. I'll show you an example using the online calculator here in a moment, but this would be essentially what you would be going for. Now, once we have this in the list, we can do one of two things. First, let's suppose you don't like hanging out on this screen any more than you have to, and you want to go back to the normal calculator. So we can add a calculator, menu, statistics, stat test. I know you're familiar with this by now, but right there, chi-squared GOF. The GOF stands for goodness of fit, and that's what we want. Now, you don't have the option to input stats like you would. It asks you for the list. You have to have already input your list into a spreadsheet. So we have our observed list, we have our expected list, and then we have the degrees of freedom. Now remember, for this data set, we saw that the degrees of freedom was 5 because there are 6 total categories, and degrees of freedom is number of categories minus 1. So we have 5 degrees of freedom there. We go ahead and hit OK, and it tells us, lo and behold, our chi-squared statistic is 10.1799, which is, when you round, 10.18, which is what we had in the notes, and then a p-value of 0.07, just like we predicted. Not predicted, but just like we suggested. So again, we would fail to reject this null hypothesis. Now suppose we don't have the TI, but instead we would prefer to use one of the online calculators. This is the calculator that I've linked for you in your resources. We are doing a goodness of fit test. That's the other option. We'll get to that later. You can title it whatever you want. And then literally don't worry about any of the rest of this. We don't care. So don't worry about this. Now, for this, you have to enter the data itself, and you have to have enough rows. So first of all, we have 6 different rows, 1 for each color, right? So there's blue, orange, green, yellow, red, brown, right? Now this part doesn't really matter that much, but it's nice to have things color-coded. Now again, we type what we observed here. So we had 9 blue, 8 orange, 12 green, 15 yellow, 10 red, 6 brown. And then our expected values, we had 14.4, 12, 9.6, 8.4, 7.8, and 7.8 again. Now, this one, unfortunately, I don't believe you can type in a equal sign and have it do the math for you. So you'll have to do the math by hand before you type in the expected values if it gives you the proportions. But that's not too complicated. You're all juniors and seniors in high school math, so you can probably do a simple multiplication. Now, all you have to do from here is hit calculate and scroll down, and it will tell you the steps that it went through to find that calculation. It'll tell you your sample size, your chi-square statistic, your degrees of freedom. It'll also tell you this thing. I have no idea what this is. We don't really care right now. And then it will go ahead and give you a visual for the graph, as well as an explanation as to what is going on. So it gives us the chi-squared statistic of 10.1799 with its p-value of 0.07. And therefore we fail to reject the null hypothesis. Again, caution with this calculator. It says the null hypothesis is accepted. As far as we are concerned, we do not accept the null hypothesis. We either reject it or we fail to reject it, and those are our only two options. Now, that's all there is to it. In this case, we would fail to reject the null hypothesis, so we would go ahead and say we do not have enough evidence to suggest that the Mars Candy Company is lying to us about the proportions of M&Ms, and we're so nerdy that we decided to go find an online calculator to help us figure that out.